Okay, so for this little video that I'm going to do today, I want to welcome you here, and I want to go over what domain and range are, and go through how we can describe them, as well as just some specifics about what the expectations would be when you're creating a domain and range for a situation and for context. Now, what domain and range are is they represent the limitations of the variables based on the context that is given. Now, when you create an equation or an inequality that has to do with a couple of variables, there may be some limitations as to which numbers you can use for those variables. Okay, and we're going to go through a couple examples as we go through here, but those limitations are what the domain and range represent. They give the reader, whoever is looking at the problem that you've done, some context as to why or what kind of numbers they can and cannot use. Okay, some of it we might think of as being very straightforward and standard, but it is still important that we put out there what values can be used. Now, sometimes that limitation is going to be based on a range of numbers, and other times it's going to be on the type of number that we can do, and sometimes there's some back and forth that we can use as well when we're doing that. So let's take a look at different ranges of numbers. Now, let's say that you have a set of numbers that someone can use that is below or above a certain value. Okay, so then an inequality can be used to describe that. So we could be talking about maybe like speed. Yeah. So on the highway, you may be driving and there might be a certain speed you're allowed to drive. Okay. Legal speed that you're allowed to drive is somewhere between that limit and below. So here where I live, the maximum highway speed is 100 kilometers per hour. And so if you are driving at 100 or less, you are allowed to do that. That is the legal speed limit and the legal driving speed that you're allowed to do. So we could represent with an inequality. And so here's a couple of examples that you could use. Okay, I have the x is less than or equal to 100 in there, which kind of represents that speed one. But maybe you have something different. Maybe your x values have to be bigger than 4. Maybe your y values have to be less than 12. Maybe your y values could be greater than or equal to -7. These are all values which could work in this case of the range of numbers that might be used. Okay, so this is where there's some limit, and then you're either above or below that you can use those. Okay, now here's another example. Let's say that one of the numbers you're using defines the age of a person. Okay, now you're looking for adults. Well, then your age, which let's say it's x would have to be greater than or equal to 18. At least where I live, 18 is what's considered an adult. And so in other words, if your age is greater than or equal to 18, we can use that number in that situation or in that context. So this is a way of describing our domain and range. The other range of numbers that we might have is, let's say that it is between two values. Okay, so from a lower limit to an upper limit, somewhere in between those two values. Now, one that you could use is something like being a teenager. Well, being a teenager, you're between 13 and 19. Those are the teenage years. So our x value, being age, would be between 13 and 19 years old, and including those, and that's where the equal sign comes in. So that could be an example. Okay, we're just giving some random examples here as to where something might be. Another one here, I have the y instead. So this is from 0 to 100. Okay, it doesn't include 0, but everything above 0, and it doesn't include 100, but everything below 100. Okay, so y has to be greater than 0, but less than 100. So it's got to be somewhere in that neighborhood. These are a couple ways that we can use inequalities to represent what the domain and range are. Okay, domain, and I forgot to mention this here, but domain is going to be your x values. Okay, what's represented with your x values. Range represents your y values. Okay, so you can use that. Now, oh, here we go. I did put it in here. I almost forgot. Domain represents the x values. Range represents the y values of an expression. And so that's where you're going to put that in. So you're going to say D or domain equals, and then give your range, and then range equals, and then give that range or that limitation to the variable there. Now there's a second way, and I'm going to put this little chart up there that you might recognize, you might have seen before. Okay, this is the number systems that we use and that we can represent. I'm going to go from kind of biggest to smallest. I'm not going to talk about the really small one, that C there, or all numbers. But I'm going to talk first about different kinds of groups of numbers and how you can use that as well. So the first one we're going to deal with is almost the outside, and that is the R, or the real number system. If a value could be absolutely anything that we can think of that's real, okay, not the imaginary ones. Well, that's that C category there. There's some other things in there. The R represents the real number system. That means all numbers. Okay, that means pi, e, square root of 2. These are not rational numbers, which can be represented by a fraction. These are irrational, which are going to be represented under the real number system. So if everything works, we can use the real number system. Now, if you're only going to use rational numbers, so just things that can represent as a fraction, so no irrational numbers, okay, you would use the Q numbers, the Q for rational number system. In my class, I will very rarely or actually never use the Q value for the questions we do, but you might get to some where you have to use just rational numbers and no real numbers. Then there's Z. Z is our integers. Okay, these are positive and negative whole numbers. Now, again, this means no decimals. Okay, so as soon as you have decimals, then you got to move up into the rational or real. But this would be with no decimals, but you could use positives and negatives. Then we have what I would consider probably the most popular one, and this here is what we call our whole numbers. So these are all of our counting numbers with a 0. So we could count 0 and then start 1, 2, 3, 4, and so on and so forth. This is what I would say is the most popular if we're talking about counting something, if we're using people, if we're using vehicles, if we're using a number of things that we're getting. Usually we get whole numbers for that, not decimals. So then we're going to use our whole number system. So real and whole tend to be the most popular ones in my category here. Then the last one is natural numbers, and so this is just the one that has it doesn't have 0, so it starts with 1. So if you can't have 0, okay, if you have to start with 1 or you have to have at least 1, you can use the natural number system. But real and whole numbers are very common. I'm going to use one example here where it just kind of goes over what the domain and range are. This is one that it just talks about what the sum of two numbers is 10. So we're told that x has to be some number, y has to be a second number, and we know that x plus y equals 10. So this gives us, if you look down there in the corner, that's where kind of all that information is laid out. Now, what are the domain and range of this situation? Well, when we're talking about the sum of two numbers, we're not given limitations on those numbers. These numbers could be literally anything. Okay, honestly, they could be literally anything. Well, at least not. They have to be real numbers. So what we're going to say for our domain is that our domain, so our x, and now you'll see that kind of funny looking E symbol there, it means a part of. X is a part of the real number system. That means that you're allowed to use every single number when you're solving this question. Every single thing. Okay, doesn't matter what. You could also say, and this is where a range will come in, okay, or a spread. Okay, it goes from negative infinity to positive infinity. Yeah, it goes like, so every single number works. Okay, and you could write that in as well, or you could say that x is a part of the real number system. Now, because x is a part of the real number system, and in this case we're just adding two numbers, what that really means is that y also has to be. So for our range, we can say the exact same thing, but now we're describing the y value. Sometimes the y value will be the same, sometimes it'll be different, okay, depending on what kind of situation we have. So for our domain and range, we are just saying and categorizing what the limitations to each variable is. Okay, what numbers can we use? What range can we have it in? And then we put it down so that someone who's reading this can understand a little bit more about what kind of situation we happen to be in. I hope this has helped with going through domain and range. If you have any questions, gladly drop them in the comments and I gladly respond to them. All the best as you work through your questions.